Okay, I will do it. Okay, so you can see that we have this signal. Okay, 20 Sinc 5 by 2t ft, and we have to find the Fourier transform here. Okay, so if we derive from this the result we get, okay, so here one result we get, no, this result we already get a rec T52528, so, okay, that's one. Okay, so I will write this result here. So if we have a pulse train, a pulse, not pulse train, if we have pulse like t by 2 tau, okay, we have the Fourier transform as, okay, what is the Fourier transform? 2a tau, 2a tau, okay, 2a tau, 2a tau Sinc omega tau. Okay, so this is the value we have. So you can keep this one in remember. Okay, otherwise you have to derive it again and again if you ask to find the Sinc function. Okay, so try to memorize, try to keep this in memory. Okay, oh, okay, you can use another form, this one, rect t by tau. Okay, now tau is there. Okay, so you have, instead of here 2 tau, here it is tau, no? So tau should be divided by 2, and 2 cancel out. So you will have a tau Sinc here. This is you can write this as tau omega. Okay, it is better because this is the constant and this is the variable. Okay, tau omega. So here you have here 2 tau, you have tau, and here you have tau. So you have tau by 2 omega. Okay, so this one or this one you can keep remember. Okay, then you can derive anything. Okay, so you can see that here we have this signal. Okay, here we have this signal. Okay, and if I draw this signal, so it will look like this. Okay, if I draw this signal, so this is a time domain signal. Okay, if I draw it, it will be like this. So the amplitude is 20. Okay, amplitude is 20, and it is a Sinc pulse, so it is go like this. Okay, and what is this point and this point, you can easily find. So this is 5 by 2 t is 5 is at 5, this will be 0, this point. Okay, so what is the t value? This 5 and 5 cancel out, t value is 2, no? T is 2. So at plus 2, it is 0, and minus 2, it is 0. And if you want to this point, you can just this 2, 2, 5. Okay, then 5 cancel out, it is 4. And this is plus 4, and this will be minus 4, like this. Plus 6 minus 6. You will have this signal. And you are asked to find the Fourier transform of this signal. Okay, so you know that, okay, you know that we have this signal. Okay, if we know this signal, any signal you can get. Okay, if you have a signal rect t by tau, okay, and the value is the Fourier transform is a tau sine tau by 2 omega. Okay, then if you have this way signal, okay, this type of signal, a tau sine tau, sorry, some signal omega naught t or something. Okay, b sine omega naught t or something. Okay, so you can easily write it. Okay, so here b, here a. Okay, so here you can write b. So you have to write with this value. Okay, so b, amplitude is b. Okay, so you have 2, 5, using the duality property. Okay, 2, 5 rect. Okay, rect. Instead of this t, you have put minus omega. Okay, minus omega. Instead of this tau, okay, here you have tau. Okay, here you have tau by 2. Okay, so the ratio is divided by 2. Okay, so here you have omega naught, so you can write it as omega naught by 2. Okay, because tau by 2, here omega naught by 2. Okay, like this. Okay, one thing I forgot to tell you is that, so I write here, I ask you to put plus 5 here, and I draw it. Okay, so you can see if I draw the minus value, it is a time reversal, no? So this part image will come to this side. Okay, this part image will come to this side like this. Okay, and this part image will come to this side. Okay, so again I have same signal. Okay, so rectangular plus 5 minus 5, it didn't change, affect the signal. So we can write rect minus tau equal to rect plus t. Okay, so this property is there. Okay, I forgot to tell you that one. Okay, so here minus omega, instead of minus omega, we can directly write it. Okay, b to 5 rect minus omega by omega naught 2, like this. Okay, it's plus here, not minus, plus. Okay, so you can now compare it with this signal. Okay, our signal is, what is our signal? 20 Sinc 5 by 2 t. Okay, so we are given 20 Sinc 5 by 2 t. So our omega naught is 5 by 2, 5 by t. So we have, okay, we have 2, 5, because our duality property, we have 2, 5. Okay, x omega, if capital xt, we have 2, 5 x omega, x minus omega. Okay, so we have 2, 5 here, and amplitude 20. Okay, and it is a rectangular one. Okay, with respect to omega minus omega, but you can use plus omega here, omega by omega naught by 2. Okay, correct? Yeah, omega naught. So rect should be omega naught by 2. Okay, so this is divided by 2. So you have 5 by 2 here. So you have to put here 5 by 4. No? Okay, correct. So here you have 5 by 2, and you have to put 5 by 4 here. Okay, so this is the answer, no? Okay, so if you draw the signal, you have, okay, if you draw the signal, you have here 20 to 5. Okay, 20 to 5, and so you can see that here 5 by 2. Okay, sorry, this is 5 by 2. Okay, 5 by 2, and here it should be by 5 by 4. Yeah, okay, okay, so we have 5 by 2, 5 by 4. Okay, so this is our duration, no? This is our duration. Okay, 5 by 4 is our duration, correct? So here we have minus 5 by 8 to plus 5 by 8, correct? So this answer you get. This is answer, no? So we have the signal this one and we find the Fourier transform of this one. Okay. So I hope it is okay. So did I do any mistake here? Here tau is there. Instead of tau, we have tau by 2. Okay. Instead of we have tau by 2. Okay. Sorry. I have done a mistake here. So instead of tau, we have tau by 2, no? Instead of tau, we have tau by 2. Okay. So instead of omega naught 2, we should have omega naught. No, sorry. Okay. Omega naught by 2, we should have omega naught. Okay. Here, instead of tau, we have tau by 2. Okay. So here, tau by 2, omega naught by 2, tau is equal to omega naught by 2. Okay, so it should be omega naught 2 here, and it should be omega naught here. Okay. Omega naught by 2, omega naught here. Okay. So here it should be 5 by 2. Okay. It should be 5 here. Sorry, this should be 5. Okay. So this is come from minus 5 by 2 to plus 5 by 2. Okay. So this is the answer. So did you guys get this? Hope it is okay, no? So you can keep, remember we have one, this, wait for a moment, okay. You have Fourier analysis, okay. Fourier analysis, and in solved problem, Fourier transform, we should have this one, okay. So you can see that, okay, you can see that if we have this kind of pulse, okay, this kind of rectangular pulse, this is our Sinc Sinc Fourier transform equation, Fourier transform frequency domain signal. Okay, and you can see that using duality property, you can this one. Okay, so you can see that here it is okay, no, PA tau sine omega naught A and sine omega naught A PA. Okay, so here you can see 5 by A, and you have minus A plus A. Okay. So you can see that here, here you can write this as minus 2 5 by 5 plus 2 5 by 5. Okay, then 5 5 you will have minus 2 plus 2. Okay, so you have 5 by A, so you can see that this is 2 and this is 2. Okay, so this is 5 by A, 5 by A. Okay, so here you have A. Okay, so here you have 5 by 2, 5 by 2. No, so it is okay. Can you understand how I verify it? Okay, so I am just compare this. Okay, I am just compare this, so you can see that here we have a Sinc pulse. Okay. Okay, here we have a sinc pulse. Okay, so what is the amplitude here? A by 5. Okay, amplitude is A by 5. Okay, and this 0 cosine point is 5 by A, 5 by A. So minus 5 by A plus 5 by A. Okay, and we have a rectangular pulse, the frequency domain signal. We have 1 minus A plus A. Okay, so I think you can remember this one. Okay, please remember this one. Try to remember this one. Then you can use this for anyone. Okay, you can derive uh, anything using this one without going through that process. Okay, so here you can see that I just convert this. Okay, so you can see that here it is in form. Here it is in form 5 by A minus 5 by A plus 5 by A, and amplitude is A5. Okay, A5. Okay, and here A5. Okay, so here with if this amplitude is A5, we have minus sorry, so we have 5A plus 5A. Okay, so so you have 2 here. Okay, you have 2 here, so I write it as 5 by A. So I write it as 5 by 2. Okay, minus, so that means this is A. Okay, so if you simplify it, you will have minus 2 here. Okay, you will have minus 2 here. So now this is like A. Okay, and here if you have divided this, okay, 5 by 5 by 2. Okay, then it is just like a 5 by A again. Okay, so 5 cancel out, then 2 will go above, so you have 2. Okay, so here you have minus, sorry, 5 by A, 5 by A, that means A is identical to 5 by 2. Okay, so here to here you should have minus A plus A. No? So A is equal to minus 5 by 2, minus A equal to minus 5 by 2, plus A equal to plus 5 by A2. So this width is okay, no? With compare with our Schaum outlines book, we have with the width is okay, and you can also see that here we have A5. Okay, A5. Okay, A5, and we have 1 here. Okay, so you can see that now our A is, what is our A? That is 5 by 2. Okay, our A is 5 by 2. Okay, our A is 5 by 2. Okay, and again we have so sorry, this A by 5 2, A5 by 2, A by 5 is equal to 20 in our case, no? Okay, okay, so here we have 1 here, nominalized 1 here, so that means we have like this 25 by, okay, 25 by, so how can we derive it? So here it is 5 by A. Okay, instead of 5 by A we have 20. 5 by A we have 20. Okay, we have 20. So here 5 by A we have 20, and here you have only 1. Okay, you have only 1. So here you have only 1. If this is A5, you have only 1. Okay, that means is A5, you should divide it by A5, no? You should divide it by A5. A5, okay? So we have 20, okay? 20, and we have 5 as 5 by 2, okay? We have A as 5 by 2. So you have, so we are putting 5 by A is here, okay, and it is mapped to 1, okay? 5 by A is mapped to 1, okay? So here, instead of 5 by A, sorry, A5, no? A by 5, we have 1 here, okay? So instead of A5, A by 5, 20, we have here, no? So it should be mapped to this way. So how can we map it? Here A by 5, and it is divided by, so to map it one, it is divided by A by 5, no? Okay. So our A is here. It is our A, 5 by 2. Okay. 5 by 2. So how we can this amplitude, this time domain, okay, we could map. So can you guys have any idea? So it is not come to my mind. So here we have A5. Okay, correct? So as amplitude, we have A5, and A5 is mapped to 1 here. Okay. A5 is mapped to 1 here. Okay. So instead of A5, we have 20. Okay. So instead of A5, we have 20. Okay. Uh, so, uh, so A5 is mapped to 1. Okay. Means so this is, so this is divided by A5. No? To map this, you have to divide this by A5. So one map you have to divide it by A5. That means 5A. Okay. So this 20 also should be divided by A5. Okay. So what is our A5? A is 5 by 2. Okay. And it is 5. Okay. So this 5 and this 5 cancel out. And we have 40. No? So there is no 5. Okay, so this 5 is not there. Okay, so we have 20 and 2. Okay, we have 40. So why this 5? We have a 5, no? So how can we can we yeah, no, yeah, that's correct. Okay, so you can see that A rect t by tau, okay, A rect t by tau, we should have here 2 5 5 5. Yeah, 2 5 should be there. Duality property, there is a 2 5. Okay, so it is a tau sine tau by 5. Okay, correct. Five is coming. No? So we have a recti 5/2, a recti 5 by tau. Okay, we have Fourier transform have 2a tau sinc omega tau. Correct. Okay, so if we have this signal 2a tau sinc omega tau, we will have a rect omega by 2 tau. This signal we have. Okay, so now we have, okay, sorry, this should be 2 5. Okay, 2 5 a rect omega 2 tau. So this is the Fourier transform of tau. Okay, so we have now 20 sinc, okay, 20 sinc 5/2 t, 5/2 t. Okay, so we should have here, okay, so we should have here, okay, 2 5 should be there. Okay, 2 5 should be there, and a should be there. Okay, so our a is 20, so 20 should be there. Okay, okay, 20 should be there, and here, sorry, we here we have ta tau. No, we have ta tau. Okay, we had tau. Okay, now this tau is identical to omega naught. This one, tau is identical to omega. Okay, that means here tau is identical to 5/2. Okay, tau is identical to 5/2. Here we don't have a tau. No? Okay, we don't have a tau. Correct. Okay, okay, we don't have a tau, and we don't have a 2 tau. No, so we should have 2 tau here. For this question, we have 2 tau. So to get rid of this 2 tau, we have to divide this point and this point also with 2 tau. Then this one cancel out. Okay, so we have sine a omega tau and 2 5 a divided by 2 tau. Okay, so this should be divided by 2 tau. Okay, so what is our tau? 5/2. Okay, so this should be divided by 2 5/2. Okay, so that means 5 5 cancelled out. Okay, this 2 cancel out, and you will have 2/20. That means 40. Correct. So we have 40. No? Yeah. So I'm sorry, I couldn't. I didn't get it at that time because I just take this in this time. Okay, I didn't do it previously. That is why I have that mistake. Okay, so I hope you get it. Okay, Did you get it? Did you understand what my mistake? Okay. So should I quickly tell it again? So anyway, we have the correct answer. Now in both way we have. Okay. So if we have a signal, okay, if we have a signal like this, 5 by A, it is 5 by A, no? A by 5, no? It is A by 5, no? It is A by 5, okay? And this is 5 by A, no? This is 5 by A. A by 5, 5 by A, 5 by A. Now we have Fourier transform as, okay, spectrum as omega, okay, x omega, okay. So here we have minus A plus A, okay. So now we have our signal as, okay, here we have our signal as 20 here, and here it is plus 2, and here it is minus 2. That is our signal, no? 20 Sinc 5 by 2 T. Okay, this is our time domain signal. So we will have like this. So I will write it like a 5 by A. Okay, so here 5 by A. Okay, so 2 should be here. Okay, so if I write it as like this, 5, okay, 5 by 2. That means 5 cancelled out and 2 come. Again, it is 2, no? And here also I can write it as 5 by 2. Okay, so this is like a 5 by A. So in our case, A is equal to 5 by 2. Correct? Okay. So A is equal to 5 by 2. So we can draw our signal. Okay. So here it is minus A to plus A. That means 5 by 2 to 5 by 2. Minus 5 by 2 to plus 5 by 2. Okay. And you can see that here A5 at A5, this is 1. Okay. So you can see that A divided by 5 is mapped to 1. Okay. Okay. And we have to map 20. Okay. 20 to some value. No. So you can see that A by 5. That means to map it 1. Okay. So you have to divide our Sinc amplitude A by 5 with 5A. Okay, with 5A. Okay, correct. Okay, so here A by 5 is identical to our 20. Okay, so we have 20 here. Okay, and we have to divide it by A by 5. A by 5. Okay, A by 5, then 5 is going up. Okay, 5 is going up, and we have A by 5. Okay, here we have A by 5, and it is 1. Okay, it is mapped to 1. Okay, and here we have 20. Okay, so how this A by 5 map to 1? Okay, so you can see that here you have A by 5. Okay, and it is divided by A and multiplied by 5, no? So that way you can map it to 1. Okay, okay, so now we have 20 here. Now we have 20 here. Okay, Okay, right. Okay, so you can see that it is divided by a. Okay, so you have a5 here, and it is mapped to 1. To map it 1, you have to divide this a5 divided by a and multiplied by 5. Then a cancelled out, then 5 you will get 1. Okay, so that is how that's where it is mapped to 1. Okay, so we have 20 here. Okay, then we have to divide it by 5 by a. So what is our a here? It is 5 by 2, no? So we have divided it by 5 by 2. This is our a. Okay, and it should be multiplied by 5. Okay, so you can see that 5 cancelled out, then 2 will come and we will get 40. Okay, so here you have 40. Okay, so this way we can get it. Okay, and if you compare that rectangular signal also, you can get the same value. Okay, because yeah, our signal, this one. Okay, a rect t by 2 to. Okay, so we have a rectangle 2 to, so t by 2 to. Okay, we have a to a tau sinc. Okay, sinc omega tau. Okay, we have get tau omega. Okay, we have get this signal. Okay, a select t by 2 to a tau sinc omega. Okay, so if you have this signal to a tau sinc tau omega, okay, sinc tau omega, sinc tau omega, you will have 2 5, this one a, okay, vector, okay, t by 2 tau, but here tau is equal to sorry, this is omega t. Okay, to a omega naught, tau is okay, you can write tau, but here it is t. Okay, tau t. Okay, so you can write it as rect to tau, like this. Okay, now we have 20 sinc. Okay, 20 sinc 5 by 2 t. Okay, so if you divide, if you map it to this, okay, so 2 5 is there. Okay, and instead of a, you have a here. Okay, but here you have 2 tau. Okay, 2 tau is here. Okay, but in this form you doesn't have 2 tau, so you have to divide this by 2 tau. Okay, and this side also divide this by 2 tau. Okay, so here this part also you have to divide it by 2 tau, no? You have to divide it by 2 tau. Now tau is 5 by 2 here. Okay, now our case, this is tau, no? That is identical to tau. So here we have 5 by 2. Okay, so tau is equal to 5 by 2. Okay, 5 is equal to 5 by 2, and that we should have divided it by 2 tau, no? And we have to divide it by 2 tau. So 2, 5 by 2, 2. Okay, so you can see that 2 cancelled out, 5 cancelled out, and we have 40 rect. Okay, rect t by 2 tau. Tau is, what is 5 by 2? That means you have 5 here. Okay, so this is the pulse width 5. So pulse width is 5, means this should be 5. That means it should be minus 5 by 2 to plus 5 by 2. Okay, and this is the amplitude 40. Okay, so our derivation is okay, no, in both the. So I hope you get it. Okay, I'm sorry at the beginning, at that point I have some confusion. Okay, so anyway, try to do these things at home. Okay, so if you can just mark this down. Okay, so I will send you a mail. Okay, I will send you a mail what you should try. Okay, so first you have to derive this kind of pulse spectra. Okay, sometimes this can be come to your exam also. Okay, this kind of question can be comes to your exam also. Okay, so it is better you should be able to do this kind of things. Okay, so you can convert this. Okay, and then try to use duality property. Okay, try to use duality property and try to derive. You can find the Fourier transform of this kind of pulse. Okay, using direct method. Then try to find the Fourier transform of this kind of time domain signal using duality property. Okay, then just take 2 or 3 sync function, and I hope you can try to do this. Okay, you can practice by yourself. Okay, so we will start. I'm sorry that the confusion I have made. Okay, hope now it is clear. Okay, hope now it is clear. uh, anyway, we will stop here because I have a meeting at 5 o'clock. Anyway, I will shift it to 6. Okay, uh, so the another thing is that you asked to evaluate the Sinc square function. Okay, Sinc square function, Sinc square function, this kind of function, Fourier spectrum. So this is somewhat lengthy. Okay, because first you have to okay, you have to uh, evaluate the Fourier transform of this kind of rectangular pulse. Okay, this kind of rectangular pulse first evaluate. Okay, so how to evaluate this Fourier transform? So you know that from here to here it is minus t plus 1. No, this function is minus t plus 1, and here to here, no, here to here it is minus t plus 1, t plus 1. No, yeah, t plus 1. It is t plus 1. Okay, if it is b, so you have to find it. Okay, so you have to, so can you do it as a homework? Okay, so try to find the Fourier transform of this kind of pulse. Okay, this is xt, this is t. Okay, say this is plus a, this is minus a, and this is 1. Okay, so first you have to get the equation for this part and this part. So how can you get it? So this is y equal mx plus c form equation. Okay, so you can see that here. Okay, this one is y equal to minus t plus 1. No, correct? No, not minus t plus 1, minus t by a. No, so you can get the value. You can imagine a point here. Okay, any point. Okay, so it is ty. Okay, ty. Okay, then you can find it like this. Okay, you can equate the gradient. No, you can equate the gradient to find the equation of this line. Okay, so how to find the equation? So this is minus a 0. Okay, and this is 0 0 1. No, this is 0 1, a 0 0 1. So you have 2 points. Okay, so you can just equate the gradient. So you have my y minus a, okay, but y minus 0 minus a is equal to y0 y0 ta, this point I get, okay. So you can get this 2 point 1 0 1 0 0 a, okay, 0 a, like this, okay. So you have y by t minus a equal to 1 by minus a, okay. So you can get y is equal to minus 1 by a t, okay, and minus minus plus 1, okay, correct, no? So this is y equal to minus 1 minus t by a plus 1. So this is the equation for this part, and you have to find the this part, okay. So sorry, this is t, yeah, no? Y minus 0 t minus a and equal to y minus 0 y minus a y minus y 0 minus a, okay. So this is the function for this part, and you have to evaluate this part also, okay. So evaluate this part also, you can get 2 points and never equate the gradient, okay. Then you can find this one and this one, okay. So you have to find the Fourier transform both signal separately, okay. So you have to find the Fourier transform this signal, okay. So this signal say xt, okay. This kind of signal you have, okay. So find that signal and substitute here, okay, and j omega t dt and plus, sorry, this is from plus a to 0, okay. Minus a to 0, sorry, this is minus a, okay. This is minus a and this will be plus, okay. That is, this is plus and this is minus, okay. Okay, because this gradient should be plus, okay. This is a plus value, no, this gradient should be plus this one. So you will have the gradient t by a, okay, t by a minus a, sorry, t minus a here plus, okay. So ta plus 1 you have here, you have y is equal to ta plus 1, okay. So instead of xd, so you have ta plus 1 e to the power j omega t, and also 0 to a, you will have same one. I think it will come as like this, minus ta plus 1, okay, like this, because gradient is minus, okay, minus ta plus 1, okay, and e to the power j omega t, okay. So you have to evaluate, you can see that here you have 4 terms, no, 0 to a, t by a, 1a you can get out, t by a e to the power minus j omega t plus minus a 0 e to the power minus j omega t dt, okay. So to evaluate this, okay, you have to find the, you have to do the integration by parts, no, integration by parts. And also you have here, you have 0 to a minus t e minus j omega t, okay. And also you have minus a to a, sorry, 0 to a, okay, e to the power minus j omega theta t, okay. So you have to integrate this 4, okay, and this one you have to integrate by parts, okay. But this one and this one you can integrate quickly, okay, and try to find the Fourier transform of this one. It should be the Sinc square function, Okay, it should be a Sinc square function. So try to do it as a homework because I have work here. Okay, so try to do this as a homework. Okay, then if you have any problem, just tell me. Then if you have a Sinc square function, okay, using the duality property, you can get the time domain signal in square domain, Sinc square signal. Okay, so you have Sinc is you have triangle function, you will have this kind of Sinc square function. Okay, and if you have a Sinc square function, okay, like this, you will have a kind of triangular function. Okay, so using duality property, this result come. So you can first try to find this kind of triangular function and try to find the Fourier series. You can done it. Okay, you should be able to done it because this integration we have done many times, integration by parts and apply the value units. Okay, then you can like we have done in this domain. Okay, like this you can have some equation, general equation. Okay, in our case we have derived, no, this kind of equation we have derived. So you can keep remember this derivation up to exam at least. Okay, then you can do it by hand. Okay, if you have the idea, and or you can keep remember this diagram. Okay, in both way you can get the Fourier transform of any Sinc function. Okay, in the same way you can derive and get that kind of general scenario to evaluate the Sinc square function spectrum also. Okay, so I will do this in another time. So try to do it at your home. Okay, at home as a homework. So we will do it another time. Anyway, thank you for being with me. I am sorry that I have done many mistakes there. Okay, so maybe it will make you big confusion, but I hope now it is clear, no? So actually the mistake is only plus minus that substitution mistakes. Okay, but procedure is okay. Okay, so what you should know is the procedure. Okay, so I have correctly uh, told you the procedure. Don't worry about that. Procedure is okay. Okay, but when I do the calculation, maybe I can do some mistake. Okay, but you should not keep remember that value. Okay, but you should keep remember the procedure. Then you can apply it to anything. Okay, any occasion. Okay, okay, so sorry. Okay, so we will wind up. Okay, thank you for being with me. Okay, Pasinu, then Ahmad, thank you for your comments and question. Okay, if you have any problem, just can tell me and you can leave the